In this video, I'm going to show you what our calculators can do in terms of chi-square. I've already shown you how once you compute the chi-square statistic to use the cumulative density function, but there is a test on the calculators. If you do stat, test, and you scroll down, and scrolling up will probably get me there quicker. There's a chi-square test and a chi-square goodness of fit test. The problem with these is that you have to do the expected values. I actually have my own program I wrote that'll compute expected values for you, but not for the goodness of fit. We have to compute those, but they're fairly straightforward to compute on the goodness of fit. But let me show you anyway. If you do have the observed values and the expected values, you have to put them in a matrix, which is above the x inverse button here. So I do second and that button, and I go over and I edit a matrix. You may see dimensions here if they're not empty, which is fine, but I'm going to do second, that button, go over and edit, and I'm going to edit matrix A. And you tell it the size, which is rows by column. This one's 5 by 2. You don't put the totals, just the actual observed numbers here. And it'll pop up a 5 by 2 matrix, which is just in math what we call a table of numbers that has certain properties. And we type them in. So we have 200, 225, 60, 110. It goes across the rows if I just keep hitting enter. 40, 50, 110, 85, 40, and 80. And then I'm going to hit second and the mode button, which says quit. Go back to the home screen, and I'm going to do it again. Second matrix. I'm going to go and I'm going to edit. Now you see A has dimensions because it has information in it. I'm going to go down to B, enter, make this one 5 by 2, and put my expected values, which again I got those by doing row total times column total divided by table total. But I got, I'm trying to move this around so I can see the buttons that I need. Okay, so I have 191.25. Again, even though in the real world you have to have whole numbers of these things, for the expected values we use the decimals, 233.75, 76.5, and I'm just going to type all these in. Two more, 54 and 66. We got whole numbers on that row. So you put in, I put the observed into matrix A, the expected into matrix B, and I'm going to go back to the home screen, and now I'm ready. Stat, tests, go find the chi-square test, tell it where you put the observed, where you put the expected. It defaults to A and B. You can calculate or draw. Let's calculate first. So there we go. There's our chi-square. Same as I got by hand, 24.067 if we round, and a p-value of 7.7 something times e to the negative 5 times 10 to the negative 5, and the degrees of freedom was 4. So that's how we do that. Let me run it again and have it draw the distribution. So chi-square test. Same information, but if we draw, it'll show us the distribution and what it's shading there. Looks like I have a scatter plot or something in my plot too, but the p-value is tiny, so we really don't see any shaded area. There's a very small shaded area out there that's rounds to 1 times 10 to the negative 4th there if you round it up. And look back at our M&M example. We can also do the goodness of fit test. Some of the older calculators, if you're still using a TI-84 or maybe even an older 84, they don't have a goodness of fit test on it, but it's been around for a while there, and my calculator has a chi-square goodness of fit test. If you have an older one, you might be able to find a program that does it. But these have to go in the list. The 2 by 2 tables we put in a matrix. These we're going to put in 2 lists. So just like everything else in stat, when we do list, stat, and I'm going to enter here to edit the lists, and I'm going to use L1 and L2, so I'm going to clear out L1. So we put our observed counts here into L1. And then we put our expected counts into L2. Don't know if the video is picking it up, but a terrible thunderstorm going on in the background right now. long as I don't lose power in the middle of the video here, it'll be okay. So you put your observed counts and then you put your expected counts, which again are from taking the proportion in the null hypothesis and multiplying by the sample size for each of those. Pretty quick to compute those. It's just a percent computation. You take your decimal version of the percent or your proportion and multiply it by the sample size for each of those. And then go back to the home screen and now stat, test, find the one with the GOF. That's the chi-square goodness of fit test. And it asks you where'd you put your observed, where'd you put your expected, L1 and L2. Calculator should be able to compute the degrees of freedom, but it asks you for it, which is 5 in this case, because there's 1, 2, 3, 4, 5, 6 categories, and 6 minus 1 gives me 5. And again, calculator draw. This time you get, as we did when we did it by hand, a chi-square of 8.05 if you round, and the p-value is about 0.15. And it also gives me the contributed values here, which are your individual chi-squares. And so that's how you do a chi-square and a chi-square goodness of fit with the calculator. You have to give it the observed and the expected values. Actually, let me finish this one. The p-value of 15%, we'll see that area. Let's do it one more time and draw. Keep everything else the same and draw. 15% is big enough you can actually see the area. There's the chi-square distribution with 5 degrees of freedom. Chi-square of 8.047 is right here, and the area in front of it's about 15%.